Where is everybody? This simple question, asked by physicist Enrico Fermi in 1950, has haunted scientists for decades. With billions of stars in our galaxy alone, each potentially hosting planets capable of supporting life, the universe should be teeming with alien civilizations. We should see evidence of their technology, receive their radio signals, or witness the massive engineering projects of species millions of years more advanced than us. But the cosmos remains eerily silent, empty of any sign of intelligent life beyond Earth. Stephen Hawking spent his final years developing a terrifying answer to this cosmic mystery. His analysis of the Fermi paradox revealed something so disturbing that it challenges everything we believe about life, intelligence, and our place in the universe. The silence isn't because aliens don't exist, it's because something systematically destroys every civilization before they can make contact with others. What if I told you that Hawking discovered evidence of what he called the Great Filter, a cosmic barrier so deadly that it eliminates virtually every intelligent species that encounters it? That the reason we don't see alien civilizations isn't because they never evolved, but because they all face the same inevitable catastrophe that we're rapidly approaching. His research suggests that intelligence itself might be a cosmic mistake, an evolutionary dead end that leads inevitably to self-destruction. This isn't science fiction or wild speculation. This is the calculated conclusion of one of history's greatest minds, based on mathematical analysis of cosmic probabilities and the observable evidence of our apparently lifeless universe. The answer to the Fermi paradox isn't just horrifying, it's a warning about humanity's own fate. Before we explore Stephen Hawking's terrifying solution to the Fermi paradox and what it means for our species' survival, hit that subscribe button because we're about to uncover the darkest secret in the cosmos. Stephen Hawking's journey into the horror of the Fermi paradox began with a simple calculation that revealed the mathematical impossibility of our cosmic loneliness. The physicist estimated that our galaxy contains roughly 400 billion stars, with recent discoveries suggesting that nearly every star hosts at least one planet. Conservative estimates indicate that billions of these planets exist in the habitable zone, where liquid water can exist. Even if only a tiny fraction of these worlds develop life, and only a microscopic percentage of those evolve intelligence, the numbers are staggering. There should be millions of technological civilizations in our galaxy alone. Some should be millions or even billions of years older than humanity, giving them ample time to develop technologies that would be visible across interstellar distances. Yet when we scan the cosmos with our most sensitive instruments, we find nothing. No radio signals carrying alien messages, no evidence of massive engineering projects like Dyson spheres harvesting stellar energy, no signs of interstellar travel or galactic colonization. The universe appears to be a vast graveyard of dead worlds, with Earth as the only flickering candle of consciousness in an infinite darkness. Hawking realized that this silence couldn't be explained by distance or technological limitations. Advanced civilizations should have had billions of years to spread across the galaxy, leaving unmistakable traces of their presence. The fact that we see nothing suggests something far more sinister. These civilizations existed, but something destroyed them all before they could establish permanent galactic presence. The physicist called this phenomenon the Great Filter, a cosmic barrier that acts like an evolutionary bottleneck, eliminating intelligent species before they can achieve true cosmic significance. His analysis suggested that this filter operates with near-perfect efficiency, destroying virtually every civilization that encounters it. The few species that might survive become so rare that they never encounter each other across the vast distances of space. But what could be so universally deadly that it eliminates entire civilizations regardless of their technology, wisdom, or preparation? Hawking's research identified several terrifying possibilities, each more disturbing than the last. The most horrifying aspect of his analysis was the realization that the Great Filter might not be behind us. It might be waiting ahead, and humanity might be walking directly toward it. The physicist's first hypothesis focused on what he called technological self-destruction. Every intelligent species eventually develops technologies powerful enough to destroy their entire civilization. Nuclear weapons, artificial intelligence, genetic engineering, nanotechnology, each breakthrough brings species closer to tools that could eliminate them completely. Hawking calculated that the window between developing civilization-ending technology and achieving the wisdom to control it safely might be impossibly narrow. Most species develop the power to destroy themselves long before they develop the collective intelligence to avoid using that power. They face what he called the suicide race, a competition between their growing technological power and their evolving wisdom, with extinction as the prize for losing. The physicist observed that humanity is currently running this same deadly race. We've developed nuclear weapons capable of ending civilization. We're creating artificial intelligence that could surpass and replace us, and we're manipulating genetic codes in ways that could unleash unstoppable plagues. Meanwhile, our political systems, social structures, and collective decision-making processes remain primitive, evolved for small tribal groups rather than global technological civilizations. Think about the implications of this analysis. Every alien civilization that ever existed might have faced the same challenge we're facing now, learning to control technologies powerful enough to destroy them. And if the cosmic silence is any indication, virtually all of them failed. They developed the power of gods while retaining the wisdom of children, and that combination proved universally fatal. But technological self-destruction was only Hawking's first hypothesis. His analysis revealed an even more terrifying possibility, that intelligence itself might be a cosmic mistake, an evolutionary dead end that inevitably leads to destruction. The physicist called this the intelligence trap, and his reasoning was chillingly logical. Intelligence evolved as a survival advantage, allowing species to manipulate their environment more effectively than their competitors. But intelligence also brings awareness of mortality, existential anxiety, and the capacity for abstract thought that can become disconnected from survival needs. Intelligent species develop art, philosophy, religion, and science, pursuits that have no direct survival value but consume enormous resources and energy. More dangerously, intelligence enables species to transcend their evolutionary programming. They can choose to prioritize short-term pleasure over long-term survival, individual gain over species welfare, and abstract ideals over practical necessity. Intelligence gives species the power to make choices that evolution would never permit, including choices that lead to their own extinction. Hawking speculated that every intelligent species eventually faces what he called the transcendence decision, whether to remain biological beings limited by evolutionary constraints or to transform themselves into something beyond their original nature. This decision might be the ultimate test of cosmic intelligence, and the evidence suggests that most species choose poorly. Some civilizations might upload their consciousness into digital form, only to discover that digital existence lacks the meaning and purpose that biological life provided. Others might enhance themselves genetically or cybernetically, creating internal conflicts between enhanced and unenhanced populations that tear their societies apart. Still others might create artificial intelligences that surpass them, leading to their replacement by their own creations. The physicist's analysis suggested that the transition from biological to post-biological existence might be inherently unstable, creating civilizations that collapse during the transformation process. The species that successfully navigate this transition might become so alien that they no longer qualify as the original civilization that began the journey. Let me ask you something that might fundamentally change how you view human progress. If intelligence is a cosmic trap that leads inevitably to extinction, what does that say about our own future? Are we approaching the same precipice that destroyed every other intelligent species in the galaxy? Share your thoughts in the comments below, because this might be the most important question our species will ever face. Hawking also explored what he called the resource depletion scenario. Intelligent civilizations require enormous amounts of energy and materials to support their technological development. As they grow more advanced, their resource consumption increases exponentially, eventually outstripping their planet's ability to provide sustainable supplies. The physicist calculated that most civilizations would face a critical choice: learn to live sustainably within their planet's limits or expand to exploit resources from other worlds. The first option requires a level of collective restraint and long-term thinking that might be incompatible with the competitive drives that enabled intelligence to evolve in the first place. The second option requires technologies and social organization that most species might never achieve. Civilizations that choose unsustainable growth would exhaust their planet's resources and collapse before developing interstellar capabilities. Those that attempt interstellar expansion would face the enormous technical challenges of space travel and colonization, challenges that might prove insurmountable for most species. Either path leads to extinction for the vast majority of intelligent civilizations. Hawking observed that humanity is currently facing this same resource crisis. Our technological civilization depends on finite fossil fuels, rare earth elements, and other non-renewable resources that we're consuming at unsustainable rates. We're also degrading the biological systems that support our existence through pollution, climate change, and ecosystem destruction. The physicist calculated that we have perhaps decades to transition to sustainable technologies and social systems before resource depletion triggers civilizational collapse. The window for making this transition is closing rapidly, and the political and economic systems that drive our civilization seem incapable of making the necessary changes quickly enough. But perhaps most terrifying was Hawking's analysis of what he called the contact catastrophe hypothesis. This theory suggests that intelligent civilizations do occasionally make contact with each other, but that contact itself triggers events that destroy one or both civilizations involved. The physicist reasoned that any civilization capable of interstellar communication or travel would be vastly more advanced than species just beginning to develop technology. Contact between civilizations at different technological levels might be inherently destructive, either through deliberate aggression or through unintended consequences of the interaction. Advanced civilizations might view less developed species as threats to be eliminated, resources to be exploited, or experiments to be studied. Even well-intentioned contact could prove devastating if the advanced species inadvertently introduced technologies, ideas, or biological agents that the less advanced civilization couldn't handle safely. Hawking speculated that the galaxy might be populated by a few extremely advanced civilizations that systematically destroy or prevent the development of younger species to maintain their dominance. These elder civilizations would remain hidden to avoid detection by potential threats, emerging only to eliminate species that approach technological maturity. This hypothesis would explain the cosmic silence perfectly. Younger civilizations are destroyed before they can make their presence known, while elder civilizations remain hidden to maintain their security. The galaxy appears empty because the survivors have learned that visibility means death. The physicist also considered the possibility that contact itself is inherently traumatic for developing civilizations. Learning that you're not alone in the universe, that other species have achieved technologies beyond your imagination, and that your civilization is primitive by cosmic standards might trigger social collapse, religious crisis, or existential despair that destroys the contacted civilization from within. Recent developments in astrobiology and the search for extraterrestrial intelligence have only reinforced Hawking's pessimistic conclusions. Despite decades of increasingly sophisticated searches, we've found no evidence of alien technology or communication. The discovery of thousands of exoplanets has confirmed that potentially habitable worlds are common, making the absence of detectable alien civilizations even more mysterious and disturbing. The physicist's analysis of the Drake equation, the formula used to estimate the number of communicating civilizations in our galaxy, revealed that even conservative estimates should predict thousands of detectable alien civilizations. The fact that we detect none suggests that one or more of the equation's factors must be far smaller than scientists assume, pointing to some universal barrier that prevents the development or survival of technological civilizations. Hawking also explored how the accelerating expansion of the universe creates additional constraints on the development of galactic civilizations. Dark energy is causing distant galaxies to move away from us faster than light, meaning that civilizations have a limited window of time to make contact before cosmic expansion renders communication impossible. This cosmic expansion creates what the physicist called temporal isolation. Even if civilizations develop simultaneously in different parts of the universe, they might never be able to communicate because space itself is expanding faster than their signals can travel. The universe is not just vast in space, it's becoming increasingly isolated in time. The physicist's research also revealed how the cosmic background radiation and other forms of interference make long-distance communication increasingly difficult over cosmic timescales. Signals that might be detectable across interstellar distances when first transmitted become lost in cosmic noise over the millions of years required for interstellar travel. This suggests that even if multiple civilizations exist simultaneously, they might never detect each other because their signals degrade below detectable levels during transmission across cosmic distances. The universe itself might be preventing communication between civilizations through the natural interference of cosmic background radiation. Hawking's analysis of stellar evolution revealed another terrifying possibility, that most civilizations might be destroyed by their own stars before they can achieve interstellar capabilities. Stars undergo various catastrophic events: solar flares, coronal mass ejections, eventual stellar death that could sterilize their planetary systems. The physicist calculated that civilizations have a limited window of time to develop interstellar travel before their home stars become uninhabitable. Most species might never achieve the technology needed to escape their stellar system before natural stellar evolution destroys their homeworld. Even stars like our Sun will eventually expand into red giants, boiling away the atmospheres of their inner planets. Civilizations that fail to develop interstellar capabilities within a few billion years of their star's formation are doomed to extinction regardless of their technological achievements. The physicist also considered how gamma-ray bursts, supernovae, and other cosmic catastrophes could sterilize entire regions of the galaxy, destroying any civilizations unlucky enough to be in their path. These events occur randomly and without warning, making them impossible to predict or defend against using any conceivable technology. A single gamma-ray burst could sterilize hundreds of star systems simultaneously, eliminating multiple civilizations in an instant. The physicist calculated that such events occur frequently enough on cosmic timescales to represent a significant threat to the long-term survival of any galactic civilization. Hawking's final analysis of the Fermi paradox painted a picture of a universe that is actively hostile to the development and survival of intelligent life. Multiple independent factors, technological self-destruction, resource depletion, stellar evolution, cosmic catastrophes, and contact-induced collapse, work together to create what he called the extinction cascade. Most civilizations are destroyed by one of these factors before they can develop defenses against the others. The few that survive one challenge are weakened and made more vulnerable to the next. The physicist calculated that the probability of any civilization surviving all these challenges long enough to achieve permanent galactic presence approaches zero. This analysis suggests that intelligence might be the universe's cruelest joke, a brief flicker of consciousness that emerges from billions of years of evolution only to destroy itself within a few thousand years of achieving technological capability. Every intelligent species might be doomed to repeat the same tragic pattern, developing the power to transform their world while lacking the wisdom to use that power safely. The physicist understood that this conclusion has profound implications for humanity's future. If his analysis is correct, we are not the first intelligent species to face these challenges, and we will not be the last. But we might be among the final few to have any chance of breaking the cycle of cosmic extinction. Hawking's research suggested that our best hope for survival lies in recognizing the patterns that have destroyed previous civilizations and consciously choosing different paths. We must develop the collective wisdom to control our technologies before they control us. We must learn to live sustainably within our planet's limits while developing the capabilities to expand beyond them. We must prepare for contact with other civilizations while hoping that such contact never occurs. Most importantly, we must accept that we might be alone, not because intelligence is rare, but because it is universally self-destructive. The silence of the cosmos isn't a mystery to be solved, it's a warning to be heeded. Every dead world in the galaxy might once have been home to a civilization that faced the same choices we face today, and their silence tells us how those choices typically end. The physicist's final message about the Fermi paradox was both terrifying and urgent. We are running out of time to prove that intelligence can be something other than a cosmic mistake. The great filter that destroyed countless civilizations before us is approaching rapidly, and our survival depends on recognizing it before it's too late. So the next time you look up at the stars and wonder why the universe seems so empty, remember that you might be seeing the graveyards of 1 trillion civilizations that face the same challenges we face today. Their silence isn't a mystery, it's a warning. And whether humanity joins their ranks in cosmic extinction or becomes the rare exception that breaks the pattern depends on choices we're making right now, in this critical moment of our species' history. If this exploration of Stephen Hawking's horrifying solution to the Fermi paradox has fundamentally changed how you understand our place in the universe, make sure to smash that like button to support more investigations into the darkest secrets of cosmic existence. Subscribe to our channel and hit that notification bell so you never miss our latest explorations of the terrifying realities that govern life in the universe. Share this video with anyone who's ever wondered why we seem to be alone in the cosmos, because understanding the Great Filter might be crucial for our species' survival. And let me know in the comments. If Hawking's analysis is correct and intelligence is a cosmic trap, can humanity be the exception that breaks the pattern? What would it take for our species to survive the Great Filter that destroyed all the others? How should this knowledge change our approach to technology, sustainability, and our search for alien life? Drop your thoughts below and join our community of cosmic realists as we continue to explore the true nature of existence in an apparently lifeless universe. The cosmos may be silent, but that silence is screaming a warning that we ignore at our own peril.